Hello sir, this is our demonstration video for our maze solving robot. So I will record this video using two simulations. The first simulation will be sped up so that we can observe the robot solving the maze at a quicker pace, while another one will just be a raw footage of the robot moving at 1x speed. So upon the beginning of simulation, this is what we can see. The user interface is displayed like so, and the robot will wait here until the start stage button is pressed. So once it's being pressed, the robot will start moving. The user interface will display several information, for example, the current state of the robot. Currently it's moving forward, the position of the robot, the time taken, and the state of the proximity sensors. So we have 3 proximity sensors. The user interface will display whether or not the proximity sensor detects a wall, and if it does, what is the distance that it picks up. So if a reset stage button is being pressed, the robot will go back to its original position as well as orientation, and we can just start all over again. So over here I will speed up the simulation to save some time. For exploration, we utilize the left wall following algorithm. So it will try to hug the left wall, and over here we can see that the robot met an obstacle in front of it as well as to the left of it, so it is forced to perform a spot right turn. But otherwise, if the robot found out that it is able to turn left, it will try to turn left. And currently the robot noticed that it has met a dead end, detecting an obstacle in front of it, to the left of it, as to the right of it, so it will perform a U-turn. And once it comes out, it noticed that it can perform a left turn, so it will perform that. And we notice that the robot is unable to move in a straight line, so we will use the proximity sensors to pick up the distance. And once we notice that the distance of the robot away from the wall is too close, a compensation will be done. So for example, over here it's too close to this wall, so it will try to correct itself, move it a little bit away from the wall until it is somewhat in the center. This is to prevent the robot from crashing, and also making sure that it stays in its desired course of movement. So the robot will perform this left wall following until it reaches the endpoint, which is at the bottom right corner, this red little dot right here. And once it reaches that, the solving stage will be performed. So I will speed this up. So now the robot is reaching the end here. So we have noticed that the exploration stage has been completed, and now it is the second stage, where the robot will be expected to solve the maze at a more optimized path. So as we can see, we have used the yellow cubes to display our optimized log path. It does not show up at situations or places where it is redundant. For example, over here, and over here, as well as over here. Previously the robot has walked through here, but now our logging algorithm is able to detect that this is redundant, so we will just pick them off. So over here, the proximity sensors will not be used anymore. We will essentially be using our lock coordinates for the robot to move. Once again, the robot will wait for the start stage button to be pressed. If it's being pressed, it will start to move. Now, once again, if the reset stage button is pressed, it will just reset once again. Since we don't have to use the proximity sensors anymore, so we don't actually have to orientate the robots around so that we can detect walls around it. To save up time, we decided to use this kind of motion for the robot where it just slides directly towards the desired coordinates instead of having to perform left turn, right turn, or spot left and right turn. So we believe that this will save a lot of time. So I'll just speed this up. In the second stage, the robot is also performing compensation at the same time while it is sliding, because we also noticed that the robot is unable to move in a straight line. So once we found out that it deviates away from the course of movement that we try to program it, the compensation will be done based on the coordinates, the current coordinates, as well as the desired coordinates for the robot to move towards to. So yeah, now the robot has solved the maze. The maze has solved the maze, and we notice that the exploration time is around 6 minutes, whereby the solving time is around 3 minutes. So I will run this simulation again at 1 time speed.